So one reason to talk about radian measure as opposed to degree measure is this notion of linear velocity versus angular velocity. And linear velocity is basically, as we know it, is the distance traveled divided by the time elapsed. And we're talking about motion around a circle. So imagine like gears going around on a bicycle, wheels going around on a car, those kinds of things. Those are all examples of angular type or motion around a circle. So when we talk about linear velocity, first of all, we call it by the letter v, at least that's what your book does. And like I said, it's distance traveled over time. Now, the distance traveled around a circle is basically the length of the arc, which is r theta. And time we're just going to call t, so time could be seconds, minutes, hours, whatever. And, so we could either say s over t or r theta over t. Now, angular velocity, and this is the Greek letter omega. Not W. I mean, you could call it W. There's no laws broken if you do that. That's the amount of angle that's traversed over time, and that angle is in radians. And what we notice is that we call it theta over t, but it's actually, so if I take theta over t and I multiply by r over r, theta r over t is v. So that means that this is v over r. So if I know the linear velocity, I know the angular velocity by just multiplying or dividing by the radius. So that means that omega is v over r, which means that v is equal to omega r. And that's going to be very useful to us at some point. So let's look at our first example here. So we have a wheel with 30 centimeter radius is rotating at a rate of 3 radians per second. So right away, I know that omega is 3 radians per second. So we want to know what is the linear speed of a point on the rim in meters per minute. Okay, so here's a point on the rim, and we basically want to know how fast it's going around. So that tells us we're looking for linear speed. So that means that v, we know, is equal to omega r. Well, omega is 3 and r is 30. So this means it is 90. Now, what are the units? Centimeters per second, because that was the units that were given in this problem. We want meters per minute. So we have to do a bit of unit conversion here. And here is how I like to do that. So I have 90 centimeters per second. I want my answer to have minutes in the denominator, and I want to have meters in the numerator. Well, the first thing I'm going to do is go after the meters. So I don't want centimeters, I want meters. So I want the centimeters to cross out, and I know that for every 100 centimeters, there's 1 meter. Okay, the next thing I'm going to go after is converting the time. Now, I don't want seconds in my answer, I want minutes in my answer. So I want minutes in the denominator, and I want seconds to go away. So that means that every 60 seconds, there's 1 minute. So that means that I can essentially just cross out the units I no longer need, which are the centimeters and the seconds. So I have 90 times 60, which is 5,400 over 100. And that's going to be meters per minute. And what that turns out to be, I'm going to have to write it over here in blue. That looks like 54 meters per minute. And there's our final answer for that one. Okay, let's take a look at number 2, and then we'll take a little bit of a break and do the others. So we have the Earth has a radius of approximately 4,000 miles. I'm going to draw another big circle. Hopefully it takes it as a circle. Yay, okay. So this is 4,000 miles. And it takes 24 hours to make 1 full revolution. Okay, so 24 hours, 1 revolution. What is the speed of a point on the equator in miles per hour? So if I just take a point on the equator there, so it's spinning around. All right, so the thing to remember is 1 revolution is 2 pi radians. So this means that the angular velocity is 2 pi radians per day. Okay. So what that means is 2 pi radians per 24 hours which turns out to be pi over 12 radians per hour. So that means that my linear velocity is the angular velocity times r equals pi over 12 times 4,000. And that is going to be, well, let's see, calculator. 4,000 times pi over 12 is 1,047.2 miles per hour. So there we have two problems where we ended up having to find linear velocity. We will see how else this can be applied in the next couple problems.